Good morning, Science 20s. Today we're going to look at two types of succession. We're going to start with primary succession and describe the key stages of primary succession in a specific ecosystem and the nature of its climax community. If we think of primary succession, that is the process of changing in successive stages an environment from an area of bare rock and few species to something we call a complex community. You will notice the starting point on primary succession is rock. That is going to be very different when we compare it to secondary succession. So starting point is rock, and our end goal is to get to a much more complex community where there is soil and grasses and trees and bushes. Primary succession occurs in places where soil have been removed, or in some cases, soil never existed. An example of this is how, let's say, the Hawaiian Islands forms, where they are releasing lava, magma, and it cools and forms hard black lava. And this lava eventually will peak out of the ocean. The moment the lava has made a solid structure and it peaks out of the ocean, we have created an island. But that island has no soil. That island has no vegetation. Therefore, it's the start of primary succession. This would also be true for things like sand dunes or mountain slopes. What you have to realize is because there is no soil, primary succession is an extremely slow process. In order to start to get to a climax community, what happens is on this rock, there is bacteria and lichens that produce acids that start to break down the rocks. These rocks then release minerals. So we can begin the idea of pioneer species beginning to form. Now, you will see on this rock here, it looks a little wet. That could be the acids, but you'll also notice that there's a little bit of green. That green is the start of a pioneer species. Pioneer species are simple, hardy plants that first invade or colonize barren ground and change the environment to support life forms. This green or this pioneer species in this example could be something like a moss. A moss is going to form and it's going to be like, okay, it's just on the surface in the beginning. But what the moss is going to do is it's going to start to decompose. It's going to start to break down. It's going to start to creep into the cracks of the rock to produce humus, or what we would say is the organic components of soil. So when you think about, hey, I have some sort of compost pile, ideally that is what's occurring in there is we have some humus and we are decomposing to make this amazing organic compost. Once this rock breaks down enough and we get enough rich, humus rich soil, then and only then will it be ready for grasses to grow. These grasses will then get replaced by lichens and mosses. These mosses get replaced then by bigger grasses or smaller shrubs. These shrubs gets replaced by taller trees. When we reach the end and we have finally got trees, deciduous and carnivorous, and grasses and bushes and all this fertile soil, then we've reached a climax community. You have gone from a pioneer species, small species that can live almost anywhere, to giant pioneer species that can harbor other animals and organisms. We need to get to the stage, though, that this rock has broken down and we've gotten soil and we've gotten enough nutrients that we can support this sort of vegetation. Our climax community is the stable community that results from the process of succession. So here we've got a picture of Vancouver Island, the Cathedral Grove. Huge trees where it would take 10 people linking arms to reach around the trunks. We do not jump in primary succession straight to this. It will take hundreds, if not thousands of years from the beginning bare rock to get to something that is so fertile, the soil, or to even have soil where we could grow this climax community. We're going to stop for a second to watch a video. Then we're going to discuss it and move on to secondary succession. Well, I love this video because it allows us the chance to see, and they have records of when lava flowed over certain areas. And so the scientist was able to take the girl on a few trips, and they saw the most recent to one that was 300 and some years ago. And you can see how we went from bare rock, pioneer species, all the way up to, I would call it close to a climax community. There was a forest there, but again, they were starting trees. They weren't really large yet. Well, here is the diagram we had on a previous slide, but I wanted to blow it up and look at it a little bit bigger. So again, we have our bear walk, and these are all of our pioneer species as we are trying to build up some soil. So bare rock, and then lichens and mosses, small plants, things that are the seeds get blown in or that they can live without a large nitrogen content. We have perennial herbs and grasses, shrubs, shade intolerant trees because there is no shade. Everything's small, so it's going to get hit by a lot of sunlight. And then once some trees get big enough, then we start to grow some smaller trees that need shade, that will only survive with shade. And you'll notice, look at how much soil, look at how much nitrogen is built up in the soil and how much soil is from the breaking down of that initial rock structure. So we are going from pioneer stage through hundreds of years to a climax community. Now, this also happens with aquatic environments or water. First, water collects in a ground depression. So I have a depression, water's going to collect. Then it's colonized by algae. Algae starts to grow. Algae provides food for other smaller organisms that find their way in. And then we have decomposing of these organisms are going to add that nitrogen-rich humus to the center again. These aquatic plants can then anchor to this rich outer soil or bottom, right? We can form grasses and stuff that are actually attached to the bottom where there was no soil before, and we can grow this nutrient-rich soil. But you'll notice then that the dugout is going to then become smaller and more shallower as it occurs. We're going to have increased vegetation growing around the water's edge, creating a bog. So we're going to have more vegetation around the edges as we go. And at this stage, we are going to transition from aquatic ecosystem to a terrestrial ecosystem, meaning a land ecosystem. We have all the soil now has covered up and been all of this soil has come and created so much vegetation that the vegetation has literally choked out the water, and therefore we lose the aquatic ecosystem and it now becomes a terrestrial or land ecosystem. So this picture works going down. We had open water and it got choked out as we added sediments until this is finally filled up and it is no longer aquatic at all. The other primary succession that people sometimes talk about is maybe terraforming Mars, or how can we get to a stage where we can live on another planet? So this would be like taking Mars and changing it so that it's a planet closer to Earth. So that means we would have to introduce very hardy pioneer species, the beginning species, plant species to Mars, so those organisms can start to begin to change the soil content in Mars. Because right now it's ungrowable. So it's one way to start a very long process. You know, it takes lots, hundreds and hundreds, if not thousands of years. And so it's one of those where most of the time when they talk about this, they're talking about maybe a dome feature where we can put a dome and we can bring in soil. But again, all of this is heavy. And so you want to kind of, I guess you have to make a decision for yourself. Should we be thinking about moving and possibly trying to live or do other things on other planets? Now, secondary succession is very different than primary succession. Secondary succession does not start with bare rock. Secondary succession does still have soil. So this could be reforestation, regrowth after a forest fire, floods, natural disasters, strip mining, clear cutting, or sometimes we have a controlled burn in order to promote regrowth of grasses, or possibly even respread of seeds through pine cones to regrow a forest. So if I compare primary and secondary succession, on the left is primary succession, on the right is secondary succession. You'll notice the big difference between these are we still have climax communities. The big difference is in secondary, we still have grasses and soil left. In primary, this is all exposed rock. So the return in stages to a stable climax community from an area that has had its vegetation removed, but not its soil. This is the definition of a secondary succession. Vegetation has been removed, but soil is still present. Because the soil is present, this will for sure be a faster process than if we were talking about primary succession. Notice this could be a forest fire. When we burn all these trees, there is a lot of good quality debris going onto the forest floor, mixing with this soil and adding nutrients and organic pieces back into this soil so that primary species will grow a lot quicker, intermediate species will grow a lot quicker, and we will eventually have a climax community yet again with mature forests. Again, if we take a look at the timeline, it could take 150 plus years to get to the climax community, but we're going to start to notice things within the first year, year and a half when it comes to grasses in this rich soil. Secondary succession occurs a number of ways. One, reforestation or regrowing from a forest fire. Two, floods or other natural disasters like hurricanes or tornadoes. Three, strip mining when we are clearing off the trees row by row and leaving it bare, but again, leaving the soil there. Three, clear cutting instead of cutting sections and then moving on, knocking out a whole forest area, but again, leaving the soil. And five, Aboriginal groups do this, but also some large parks in Canada also do this, where we plan to burn a section of forest in order to promote regrowth of grasslands, a regeneration of grasslands, or possibly, right, if I heat up some of those hard pine cones really, really hot, like in a forest fire, when they get really, really hot, we can heat them up till they explode, and that's when they'll finally spread their seeds, and it'll start the process again of regrowing a natural forest. Well, having grown up in Alberta, I think most of us realize some problems that national parks like Banff or recently Waterton or Jasper have had to deal with, and that is secondary succession in the national parks. When there's a forest fire, we try our best to quickly put out the fire and stop the fire. However, because the fire does burn, there are consequences of this. One consequence is coniferous trees or conifers expand to a greater degree because they burn and their pine cones get really hot and explode and spread out their seeds. We will get a thicker forest. Now, we don't have the forest right away. Again, it's going to take hundreds of years, but we will get the forest. What we will also notice, though, as a consequence, is a decreased number of certain animals like deers and elk and moose, those sorts of animals that graze in these regions. And with the trees burnt down, one, they lose food sources. There's no grasses, there's no leaves, none of that. Two, there's also nowhere for them to hide. So it threatens the animals' environment because they have a very limited habitat in which they can live and very limited space where they can find food. And when these forest fires from secondary succession takes place, yes, the tree population expands, but the animal population either decreases because they die off or they have to move on to a brand new region. Well, my question to you is why would the average Aboriginal people decide to intentionally burn their vegetation? Well, one of the reasons would be the chance of a massive, more dangerous fire might be coming. So we do also do this trick in national parks where there's a small fire burning. In order to know to stop it, we get ahead of it and we burn a section which is controlled burning so that and put it out. So by the time the fire gets to that section, there's nothing left to burn and all it's going to do is run out of fuel, dead wood or grasses or dry bushes to burn, and it's going to stop and we'll have contained it. The second reason is the Aboriginal people might be promoting growth of meadows and vegetation that they might need for medicines or possibly attracting larger animals that they can hunt for a food source. We're going to watch one last video before this is finished. I'm going to make this guy a little bit bigger if I can. Oh, I don't know if I can. Let's see if we can trick this. There we go. We are going to trick it. Now let's watch this video a little bit bigger and then we'll finish off. Okay, so I like that video because it goes straight from primary to secondary. Again, the biggest difference, primary goes all the way back to rocks. Secondary still has soil so that you can grow your pionary species more quickly.